What up, 8th graders? I'm going to show you guys how to do part 2 of the assignment we started yesterday, which was the pHet gravitational force. So this was the one where you guys had the little humanoids doing their thing with the balls. Okay, and yesterday you guys kind of just experimented with changing the mass of each of these objects and also changing the distance between each of these objects and seeing how force acted upon them. Today what you guys will be doing will be graphing some results. You guys will actually be collecting some data on this, but also graphing these results. So for this, you guys should have this Excel document opened up. So you guys will be submitting this as part of your guys' assignment today. So this is in as well your team's assignment. And we're just going to kind of go through the first part together, and then I'm going to get you guys started on the second part of this, and then we will, you guys will finish it on your own. So the first part, this is part 2 experimentation. Again, you guys did this part yesterday. Okay, so for experimentation, it says, how does the gravitational force that a small mass has towards a large mass compared to the force that a large mass has towards a small mass? Okay, so we're going to go ahead and write a hypothesis. If we increase the mass, okay, the blank will increase or decrease. So what we're looking at this is if we increase the mass, what are we measuring in this lab? So if you guys remember, if we go back into this, if we're increasing or changing the mass, what effect does that have? Okay, so if you guys said gravitational force, you are correct. So if we increase the mass, the gravitational force, so in here I would type in gravitational force, or just force is fine too, will increase or decrease. So if you guys increase the mass, you guys should see, oops, sorry, wrong thing. If you guys increase the mass, you should see an increase of force as well. So our force was getting bigger. So you're going to say increase, so you can go ahead and highlight that. Because blank. So why do you think that is? Okay. So you guys can give me an explanation. If you guys added the gravity notes yesterday, you guys could probably find some help in there. And then same thing here, if we increase the distance, now if we're looking at restarting this and changing the distance between these two objects, what does that do to your force? If it helps, look at the arrow versus the numbers. So as we get closer, what happens to the size of the arrow? As we move further away, what happens to the size of the arrow? The sound effects are really what makes this better. I could have muted them, but I didn't want to. All right, so again, do that same thing. If we increase the distance, what happens with the gravitational force? It's also what we're measuring. Okay, and then why do you think that is? All right, so let's look at this first one together. So what we're going to be doing on this first one is we're going to be entering some data into Excel. You guys can ignore the data in this table right here. And then once we're got entered into Excel, okay, we are going to graph it, and I'll show you guys how to walk through that as well. All right, so the first thing I'm going to show you guys is how to collect your data. So if it helps you, what I would do is I would pull up your Excel worksheet, and then I would split your guys' screen. So on one side you have your Excel worksheet, and on the other side you guys have the pHet simulation. Okay, I'm going to go ahead and restart and reset my guys. But basically what you guys are looking at is if we change the size, we're not going to mess with the distance, because if we mess with the distance, we're not going to know if our force is changing because of our distance or our mass. So we're just going to isolate and do one thing at a time. So if we change the mass of just one object, in this case we're going to do the blue object since it's already kind of set at the bottom for weight or mass. We're going to just change that. That's going to be called our independent variable. That's the thing we're changing. And then our responding variable or our dependent variable will be the force. So we're going to change the mass and see what happens to the force. So it's kind of like a cause and effect. If I change this mass, what effect does that change have on our gravitational force? Okay, so we're going to pick 10 data points. In this case, our 10 data points are going to be our mass in increments of 100 kilograms. So our very first thing that we're going to do is just read the first the first data they give us, and we're going to plug it in over here. So our first force at 100 kilograms for our mass is going to be 0.000000166 852. Do not use scientific notation for this. So if you guys use scientific notation, this little option here, for your first part yesterday, today you just want the decimals, okay? Because when you guys hit enter on Excel, it's gonna put it into its own type of scientific notation, and it's not gonna be the same way that you guys enter it into the computer. So if you guys enter it in the way that you're used to, or the way it says over here for scientific notation, your graph is not gonna turn out right. So just plug in the decimal, okay? And then what you'll do is then increase your mass to 200 grams and take a reading for your force. So 0.00000333704. Okay? So I'm going to do that from here to 300. So then I'm going to go to 300 next. I already have the data taken for you guys, so I'm just going to go ahead and copy that and paste that in. Control C. And the rest of my data is right here. Control V. And so that's all my data if I were to go through and change this by 100 kilograms every time and collect my data. Okay, so that's the first easy part. Now let's focus on the graphing part. So if we go back to our worksheet, okay, notice that these values are slightly different. I think they changed the simulation since then, so I must have done different weight increments. So don't worry about that. And then it says, which quantities do you need to hold constant? So what things didn't we change? Okay, we changed the mass of the blue object, but what things did we want to keep the same each time? So which variables did you not manipulate or see a change as a result? So the main thing you're going to see is we didn't move the distance. Okay, we kept those two humanoids holding their objects at the exact same distance apart, and we also didn't change the mass of the red ball. We just wanted to isolate one and see what happened. Okay, so now it says use Excel, create an Excel doc in your Edmodo assignment to make a graph of mass and force. So you guys would insert your graph here, okay? You already have a graph in there for you, but we're gonna go ahead and add one together. So I'm gonna show you guys how to do this. So when you need to, you guys will need to make a graph for distance, which we'll talk about here next, okay? This is gonna be the same instructions that you guys used for that, except we're gonna be graphing mass in this case. So what you will do is you'll highlight just the numbers. Do not highlight mass or gravitational force, or in the case of the one you guys do by yourself, distance and gravitational force. So just highlight your numbers. So click and drag until this column of numbers and this column of numbers are both highlighted. Then you'll go up to Insert, and we're going to go to all of our graphs here. You guys are going to want to go down to this option that says Scatter. Okay, so we're going to do, let's see here. Let's do, I guess it really doesn't matter. So we'll do scatter with smooth lines and markers. Okay, and then this is great and all, but this, I mean, in the science world, this is just not a good graph because we don't have a title. We don't have a title on our y-axis. We don't have a title on our x-axis. And because we only have one line, we don't really need this key either. So we're going to tweak some things here. So first thing you're going to do is go Chart Title. And we're going to select above chart. Mr. Mergel says hi, you guys. If you have him as a teacher, I apologize immensely.
Who's on?
It's a video. I'm making a video.
Oh, I thought they were really on there.
Oh, he just wanted to talk to a real person because no one will talk to him. All right, so anyway, you guys are going to do a chart title. Your chart title will be over, and then you guys will go edit chart title. So when you guys are choosing a chart title, you guys are going to choose something that reflects both your x and y axis. Right now on our x-axis, we have our mass, and on our y-axis, we have our gravitational force. So you should have mass and gravitational force somewhere in your title, okay? It could be like mass versus gravitational force. It could be something like how mass changes gravitational force. It doesn't matter as long as you guys have mentioned that there's going to be some relationship between mass and gravitational force. I am always a big fan of mass versus gravitational force. Okay, so that's the first thing you need to do is change your chart title. Then if you look right here, you can see axes titles. So let's go ahead and change our primary horizontal. So if you guys think of a horizon in a picture, the horizon runs left to right. So that's your x-axis. So primary horizontal axis, we want title below axis. And then we're also going to want to edit it and say, all right, what is our x-axis? What did we use? In this case, mass. And then you always want to include a unit. How did we measure our mass? Okay, so we're in kilograms for that one. So we're going to put parentheses kilograms after. Okay, then on to our other axis title, which is our vertical. So vertical is up to down, so that's your y-axis. We're going to go a rotated title. So that means it's going to flip it and it's going to write it like this. Okay, and for that one, we're going to use gravitational force. And we're going to include the unit. What unit do we use for force? In this case, newtons, so capital N. So in parentheses, we'll add a capital N afterward. Okay, and last but not least, since we only have one line, we don't need a key. Okay, so you guys can go to legend and then just go none. Turn it off. Okay, so that should be what a final good graph looks like. Okay, so what you guys will do for distance then is if you guys click this tab at the bottom right below that says distance, you guys will go ahead and chart out your distance. For the most part, you guys can choose whatever distances you guys want, but my suggestion to you guys would be to keep it simple, okay? So if it helps, you guys are gonna start the closest, would be my suggestion. Start at 1 and say, all right, let's make both of our masses the same. Let's make them both 100 just for the sake of keeping it easy and being able to get them close together. This is going against all social distancing that you guys know right now, but good thing these are humanoids and probably can't get COVID. All right, so here we have our two objects. Both of them are going to be the same size just to make it easier for us. And we're going to go ahead and start. So this is our center here. We're going to move this guy back so the center is lined up right at 0. And we can drag the red guy over and try to get him as close as possible, okay? He's pretty close to 1, but not quite all the way there. If that's the case, let's take our objects down to maybe 50 so we can get him exactly 1 way. There we go. All right, so now it looks like we can get them lined up evenly. So now I have the blue one exactly over 0 and the red one exactly over 1. The distance between them is going to be 1 meter. It's the distance between the center of them. Okay, so yes, there is not a full meter in between them, but between the radii, which is where we're going to focus on for all of these, so it won't really matter, is going to be exactly 1 meter. So your distance between those two objects would be 1 meter. And then you guys can go ahead and look at the force. Your force is going to be 0.000000166,852. Okay, then your next distance could be 2. This is just one example of how you guys can do it. If you have another idea of how you guys want to do your distance or how you want to do your increments, maybe you guys just go by half. So you're like, all right, I want to start there and then I want to go by a half a meter instead of a full meter. That's up to you guys. You just need 10 data points. So in this case, I'm going to do 2. So if I were to continue on this way, I would have 1, 2, and then clear through 10 meters apart. Okay, so I have 10 data points there. You will need 10 as well. Okay, so however you choose to do that, if you guys just want to go by, it looks like 1 little dash, you guys could do that. So 1/5 of a meter, totally fine. And then you guys will collect your guys' force data, and then you'll do the exact same thing. You guys will graph it. Okay, and then to get your guys' graph, don't forget to change. Once you have a graph, just like we did on this, don't forget to change your guys' title. So it talks about distance and gravitational force. Change your guys' y-axis to say gravitational force, and then what would go on your x-axis. So that would be your guys' distance in meters. Okay, so little m. So you guys will collect your data for that. And then you guys will get a graph that looks somewhat similar, but not quite the same. Your line should not look exactly the same as this. So you'll get that, and you guys will go ahead and fill in your information for this. Since you guys have this in Excel already, don't worry about filling out this distance table. It's just you guys writing the same numbers twice. That's no need for that. Okay, so do it all in Excel's. Which quantities did you need to hold constant? So which ones did you not change on that one? So it should be different than what you guys answered over here on this one. Okay, here's your guys' graph, so put your graph in right here. Which quantity went on the x-axis, and is the resulting graph linear? What that means is it a straight line? So if we look back at this first graph we did, is that a straight line? then yes, it is linear. Okay, so is the resulting graph linear? Which equation would you use to make a trend line? Don't worry about that one. But for those of you guys who are in math and doing graphing, your answer would be y equals mx plus b. So don't worry about answering that question. And then let's talk really quick about independent and dependent variables. So your independent variable goes on the x-axis. What did we put on the x-axis? That's the thing that we directly changed. We went in and we changed the mass of each of those humanoids objects. Okay, so that was our x-axis. And then down here, you guys would answer the same question. So then it says, write a summary for each of the two hypotheses explaining the relationships you saw. So what was the relationship between mass and gravity and distance and gravity? If you increase the mass, what happens to gravity? If you decrease the mass, what happens to gravity? If you increase the distance between two objects, what happens to that gravitational force? And if you decrease the distance between two objects, what happens to that gravitational force? Do you guys think they're directly proportional? What that means is if they're directly proportional, if one goes up, the other goes up. If one goes down, the other goes down. So you see that same increasing or decreasing trend. Indirectly proportional would be kind of opposites. If one goes up, the other goes down. Okay? Or if one goes down, the other goes up. So which did you guys see? Directly proportional or indirectly proportional? And then answer some of these wrap-up questions. And that will be your guys' assignment for today. So yesterday you guys should have finished part 1. Let me know if you guys have any questions. Again, if you need to review this video on help with graphing, but it all should be there for you guys. I hope you're all having a great Friday, and I will talk to you soon.